Hi, I'm Adam. In this video, I'll be covering how your app can help people manage their time with Calendar and EventKit. First, I'll go over some ways that apps can integrate with Calendar and give an overview of the frameworks involved. Then, I'll walk through some specific examples of how to use these frameworks to implement common features like adding events, fetching events with full access, and implementing a virtual conference extension. People rely on their calendar to keep track of their time and plan for their future. But Calendar is more than just one app. There are different roles that apps can fill when integrating with Calendar, and when put together, these different roles provide for a richer calendar experience. Some apps support making reservations, buying tickets, or arranging meetups. They take part by adding events. Some apps participate by displaying events, maybe for a custom calendar widget or a planner. Other apps contribute in both directions. They help people manage their schedule by viewing and editing events. Apps that support voice or video calls can also take part. A virtual conference extension not only improves the experience in the Calendar app, but it also provides a shortcut back into your app. All of these fit together to provide a cohesive experience for managing time. Later, I'll walk through some specific examples to get started in each of these areas. There are two frameworks that you can use to integrate with Calendar. The EventKit framework is used to work directly with Calendar data. EventKit UI is an iOS and Mac Catalyst framework that provides view controllers for showing Calendar UI in your app. Let's take a closer look at each. Starting with some of the basic types in EventKit. The EK Event Store is the main point of contact for your calendar data. You use an event store to request access and to fetch or save. You should only have one of these for your application. The EK Event class represents a specific event, and it has properties like title, start date, end date, and location. Each event belongs to a calendar, which is represented by the EK Calendar class. Calendars have a title and color, which can be useful for coloring the events. Finally, each calendar account is represented by an EK source, which is a collection of calendars. Sources are useful for grouping calendars in your UI. EventKit is a foundational framework for interacting with calendar data. EventKit UI is built on top of EventKit to provide some useful built-in views. There are three view controllers provided by EventKit UI. The EK Event Edit View controller shows an event editor. Use this to add a new event or make changes to an existing event. The EK Event View controller shows event details. Use this to show information in your app about an existing event. And the EK Calendar Chooser shows a calendar list and supports either single selection or multiple selection. Use this to let people choose a calendar to add an event to, or choose which calendars should be visible in your app. Calendars are private, so the system prevents apps from reading or writing calendar events without permission. There are three levels of access that an app can have for Calendar: no access, write-only access, or full access. Apps with no calendar access can add events using EventKit UI or Siri event suggestions. Apps with write-only access can add events directly using EventKit. And apps with full access can fetch or modify existing events, access existing calendars, and create new calendars. One of the most common ways to integrate with Calendar is to add new events. Events can be added to the calendar in a few different ways. Use EventKit UI or Siri event suggestions to add one event at a time. Or, to save events directly, use EventKit. The simplest way to add an event to the calendar is to let EventKit UI do most of the work. Present an EK Event Edit View controller to show an editor with the event details filled out. This gives people a chance to choose a calendar or make other changes before deciding whether to save the event. In iOS 17, this UI runs in a separate process, which means you don't need to request calendar access. Adding an event with EventKit UI is a 4-step process. First, create an event store. Next, create an event and fill in the details. Then, create a view controller configured to edit the event. And finally, present the view controller. Let's walk through this in more detail with some code. Start by creating an event store. Next, create an event and fill in the details. The details you set here will be used in the editor UI. Once the editor is presented, people will have a chance to make changes, but ideally, they can just tap the Add button to confirm, so filling in the right details saves them time. Every event needs a title. The title is used in many places, including widgets and notifications, so keep it simple. The most important properties are the start and end date. Use date components to make the start date. Once you have the start date, calculate the end date by adding the duration. Use Foundation's calendar and date components types for date math, or else you'll hit surprising results around daylight saving time. Here, the sample adds 2 hours to our start date. If the event takes place in a specific time zone, then be sure to set that as well. The default time zone will be the current system time zone. Set a location to let people know where the event takes place. Including a full address or using a MapKit handle will enable features like map suggestions and time to leave alerts. Finally, add some notes to provide some extra detail. Once you've set the event properties, the next step is to create the EK Event Edit View controller. Assign the event and event store properties. In the editor, people can either add the event or cancel. If you want to know whether they added the event, then use the delegate property and implement the EK Event Edit View Delegate protocol. Finally, present the editor. At this point, the event isn't in the calendar yet. Tapping the Add button will save it, while tapping on Cancel will dismiss the editor without saving anything. For a more complete example of adding events with EventKit UI, check out the drop-in lessons target in the Accessing Calendar using EventKit and EventKit UI sample code. Another way to add events to the calendar is to use Siri Event Suggestions for reservations made in your app. The Siri Event Suggestions API is part of the Intents framework. It doesn't require prompting for calendar access, and it doesn't show any UI in your app. Instead, these events will appear in the calendar inbox, like an invitation. They can then be either added to a calendar or ignored. Siri Event Suggestions support reservations for restaurants or hotels, travel bookings like flights or rental cars, and ticketed events like concerts or sporting events. If the reservation is later canceled or modified, the events can be updated. Using the Siri Event Suggestions API is a 4-step process. First, create an IN reservation. Then, wrap the reservation in an intent and response. Next, create an IN interaction. Finally, donate the interaction to the system. Let's dive into some sample code. A reservation requires a unique reference that the system will use to identify it. Create that reference by making an instance of IN speakable string with a unique vocabulary identifier and a spoken phrase. The phrase can be used to refer to this reservation when talking to Siri. Use IN date components range to set the start and end time for the reservation. Give the event a location using the CL placemark type. Then, put that all together by creating an instance of one of the subclasses of IN reservation. For a restaurant reservation, use IN restaurant reservation. This initializer has a few more optional arguments that aren't shown, and each subclass has its own specific options. Check out the documentation to learn more. The next step is to create an INGETReservationDetails intent with the reservation reference. Then, create an INGETReservationDetails intent response with the reservation object. Next, create an INInteraction with the intent and response. Finally, invoke the interaction's donate method. This example only scratches the surface of what can be done with Siri event suggestions. For more information about creating Siri event suggestions, check out the Broaden Your Reach with Siri Event Suggestions video from WWDC 20. EventKit UI or Siri Event Suggestions provide the best experience for adding events. Use write-only access only if your app needs to show a custom editing UI, add multiple events at the same time, or add events to the calendar without user interaction. To request write-only access, include the NS Calendar's write-only access usage description key in your info plist to explain why your app needs access. This string will be shown in the request prompt. Here's the prompt for our sample application. Save repeating lessons to a calendar that you choose. Write-only access also has some limitations. For one, people may choose not to allow access. If access is granted, then the app still cannot read any existing events from the calendar, including events added by the same app. The app also can't read the calendar list or create new calendars. Write-only access is new in iOS 17 and macOS Sonoma. To learn more about how this affects existing apps, check out the What's New in Privacy video. Adding a new event with write-only access will look similar to adding a new event using EventKit UI. It starts out the same: create an event store. Then, request write-only access. If access was granted, create a new event and fill in the details. Lastly, save the event. Let's check that out in more detail. Start by creating an event store. Then, request write-only access by calling the request write-only access to events method. The return value indicates whether access was granted. People can choose to deny access, so be sure to handle that gracefully. Access requests are most likely to be approved when people understand why your app needs access, so you should request access when someone has first interacted with a feature that requires it. Next, create an event and fill in the details. There's another important difference here. When using EventKit UI, the details you fill in will show up in an editor, and anything not filled in gets a default value. When saving an event directly with EventKit, nothing will be filled in for you. What you set is what will be saved. There are some properties that must be filled in, or the save will fail. One required property is the calendar. Use the Event Store's default calendar for new events property to use the calendar configured as the default in settings. The other required properties are title, start date, and end date. Everything else is optional, but it's good to fill out as much as possible. Once the details are filled in, save the event using the Event Store's save method. To see a full example of adding events with EventKit, check out the repeating lessons target in the Accessing Calendar using EventKit and EventKit UI sample projects. Apps that want to add events to the calendar should use EventKit UI, Siri Event Suggestions, or write-only access. For the very few apps that need to read calendar data, there's full access. Only request full access if your app has a core feature that requires displaying, updating, or removing existing events. To request full access, include the NS Calendar's full access usage description key in your info plist. This string will be shown in the request prompt. Calendars contain sensitive information, and the prompt for full access describes how much data is included. It takes a lot of trust for people to allow an app to read their calendar. If people don't yet trust your app, then the request may be denied. Only request full access if it is essential to the core experience of your app, and only request at a time when it is clear why the access is needed. If your app does need full access for a core feature, then it will probably need to fetch events. To do this, first create an event store. Next, request full access. Then, create a predicate. And finally, fetch the events from the event store. Let's check out the code for that. As with our other examples, start by creating an event store. Apps should only have one event store, so be sure to reuse this. Next, request full access by calling the request full access to events method. This will show a prompt and return whether the access was allowed. Full access prompts will be denied more often, so be sure to handle that. Once you have full access, create a predicate by calling the event store's predicate for events method. The predicate describes which events you want to fetch, with a date range and an optional list of calendars. This code uses a range for the current month. Use the shortest range possible for the best performance. If the calendar's argument is left nil, the results will include events from all calendars. Finally, fetch the events by passing the predicate to the event store's events matching method, which returns an array of matching events. The events in this array are not necessarily ordered, so sort the results if needed. If you want to play around with a full example of fetching events, then check out the monthly events target in the Accessing Calendar using EventKit and EventKit UI sample project. To support releases earlier than iOS 17 and macOS Sonoma, perform a runtime availability check. Call the new request access methods on iOS 17 and macOS Sonoma and beyond. On earlier OSs, call the legacy request access method. Additional usage strings are required prior to iOS 17 or macOS Sonoma. Include the NSCalendar's usage description key for requesting calendar access. Apps that use EventKit UI also need to include the NSContacts usage description key, because EventKit UI will request contacts access for the app. If an app is missing these strings when requesting access, then it will crash. So far, we've covered a few ways to add events and how to fetch events, but working with events is not the only way to integrate with Calendar. If your app supports voice or video calls, use a virtual conference extension to let people add your calls directly to their events. There are two ways that these extensions are used. When adding a location to an event, custom virtual conference options will appear in the location picker. This example has the options provided by the FaceTime and Skype virtual conference extensions. Tapping on one of these will add that virtual conference to the event. An event that has a virtual conference will show a custom Join option in the event details. Making a virtual conference extension takes just a few steps. First, create a new virtual conference extension target in Xcode. Then, there are two methods in the extension protocol to implement. Implement fetch available room types to provide your available room types, and then implement fetch virtual conference to provide a virtual conference object for a selected room type. Let's walk through an example. First, create a virtual conference extension target in Xcode. The new target will have a stubbed subclass of EK Virtual Conference Provider. The first method to override is fetch available room types. The room types are shown in the location picker. Choose a title for each room type. This will be shown in the UI next to your app icon. Also, choose a unique identifier for each room type. The identifier is used to let your extension know which room type was chosen. Create an instance of EK Virtual Conference Room Type Descriptor using the title and identifier. If your app supports multiple room types, then make an instance for each one. Finally, return an array of your room types. The next method to implement is Fetch Virtual Conference. This is called when one of the room types is selected. The identifier argument tells you which room was selected. Virtual conferences have one or more URL descriptors, which tell Calendar how to join. Create an EK Virtual Conference URL descriptor with the URL to open and an optional title. Use universal links for your URL to allow your app to be opened directly. The title helps to distinguish between multiple join options. Here it's not needed because there's only one way to join. Provide any additional information in a details string. This text will be included in a special virtual conference section of the Event Details UI. Finally, put all of this together to create and return an EK Virtual Conference descriptor. The title here helps distinguish between multiple room types. This example only has one room type, so the title is left nil. With just these two methods, your app will appear in the Calendar app's location picker as an option for virtual conferences. Now that we've covered a few different ways of integrating with Calendar, think about how your app can contribute. Use EventKit UI or Siri event suggestions to add events without requesting access. If you do need to request access, request the minimum access needed and only when it's needed. And if you have a voice or video call app, then implement a virtual conference extension. I can't wait to see how your app integrates with Calendar. Thanks for watching.